Good start? Excellent. Right, good morning all. Hello, welcome to day 2 of DevOps UK. I'm Simon, and this session is going to be about software architecture, which is normally what we consider upfront design to be, and how we balance that with agility. Quick intro to me. I live here in Jersey in the Channel Islands. It's a small blob somewhere between France and the UK. Prior to moving back to Jersey about 5 years ago, I actually worked here in London, and I mostly worked for consulting companies building systems in Java. There's a whole long story about why I ended back up in Jersey, but essentially this slide should say everything. Right? It's a really nice place to live. That's it. Jersey shall henceforth be known as Simon Brown's Island. So I got a brilliant T-shirt done by the Smart Up Visual guys yesterday, and that's what they put on the back of my T-shirt. So what do I actually do? I'm a software developer, and over the past couple of years, I've been jetting around most of Europe, helping software teams understand how they can do software architecture and still be agile. I do write code, so this isn't about to get all fluffy and conceptual and abstract and that sort of thing. And my whole pitch here is basically that software architecture needs to be much more accessible than it already is. If anyone's tried to read any of the classic architecture books, Clements and Bass, those sorts of things, they're very, very good books. But they tend to come at this from a very kind of academic research perspective. So when I was moving into my first architecture roles, I found it really hard to figure out how those books mapped to my day-to-day career. So I put my own book together about 2 years ago, which is finally finished. I say finished in air quotes because it's an ebook and we can change it anytime we want to. If you guys hang around till the end, and I hope you do, I'll give you a discount code so you can buy this. So let's start from the start. What's agility all about? Well, agility and agile and being agile means many different things to many different people. But these are some of the common themes that we often talk about. So moving fast, embracing change, releasing often, getting feedback, those sorts of things. It's also about a bunch of fluffy stuff. So I went to a conference in the US last year. It was one of the Agile Alliance conferences. And it was a brilliant conference, but it was super, super fluffy. It was all kind of having hugs in the morning, your stand-ups, giving each other good feedback, that sort of thing. Right? That's a very, very different set of stuff. We're not going to be talking about that. So what happens if we put the word agile in front of software architecture? What does this actually mean? Well, one of the big things we've done in industry is use a lot more sticky notes. So this is not agile architecture. Just because you can draw pictures of sticky notes and you can move them around, this is not what we're talking about. And what is also worth bearing in mind is just because you're delivering software in an agile way, this does not necessarily guarantee you're going to create an agile architecture. And agile teams do not necessarily deliver agile architectures. What do I mean by this? Because we're focusing on delivering user stories and features, often we neglect some of the underlying architectural stuff. And therefore, those architectures, those softwares tend to be hard to change because we've not put consideration into adding flexibility into our systems. So for me, an agile architecture is one that basically reacts easily to changes in its environment, changes in requirements, that kind of thing. But of course, there are different styles of architectures, aren't there? Right, we can create our systems in very different ways. This is the typical way we build software. We have a single deployable monolith, and we chuck it out into a production environment, and people use it. Is this agile? Does this give us the ability to flex and change? Maybe. A lot of people write off the monolith because they associate the monolith with the big ball of mud style of architecture. So if your monolith is truly a big ball of mud, yeah, that's going to restrict your ability to change and therefore be agile. We can build systems in different ways, though. We can use service-based or microservice style architectures. So instead of having a single deployable unit, you have a bunch of deployable units that do one thing and do one thing very well. Very small services, for example, all communicating via REST or SOAP or messaging, that kind of thing. These architectures tend to give you a lot of agility because you can substitute any of these services whenever you want to. This gives you lots of options for deployment, scaling, availability, reliability, redundancy, that sort of thing. So really what we're talking about here is a good architecture is the thing that enables agility. So if you have a good architecture, it's a thing that gives you the ability to change your system quickly. But of course, nothing's free, right? There are these different ways of building software systems, but they all have trade-offs. On the one hand, we've got the monolithic style of system. These generally are easier to build. Right? The IDEs, the toolings, the tutorials, the books are all set up to describe these monoliths. But depending on how you implement them, they can be hard to change. Over here, when we look at our service-based architectures, our microservice architectures, these buy you a lot of agility, a lot of flexibility, but they're more complex to create. Why? Because you're having to deal with a lot of other stuff now around your environment. You know, spinning up hundreds of servers potentially, running all these different microservices. I'm staying in the Hilton Hotel next door, and I've noticed this at the last couple of hotels I've been at. When you get your cereals and you pour your cornflakes into your bowl, you get 2 jugs for milk. One's full fat and one's skimmed. They're both horrible, right? There's something in the middle, but you never get offered that middle choice. We can still deliver monolithic systems with components inside them. So there is a nice midpoint here that we can try and aim for. Now, I'm not going to preach to you and say that component-based architectures are the silver bullet, the way forward, but what I'm saying here is there are different styles of architecture depending on what you're trying to do. So one of the things you need to look at is how much agility you need in your environment, and then pick the appropriate architecture to fit those needs. So what does agility actually mean? Right? If we boil this down to its essence, what's agility really about? There's a guy called John Boyd. John Boyd was in the US Air Force, and he was a fighter pilot. And he created this concept he called the OODA loop. Observe, orient, decide, act. So picture the scene. You're flying around in your jet, and there's an enemy behind you. And what are they trying to do? They're trying to shoot you down. So in his fighter pilot training, what John Boyd says is, in that situation, you need to observe the situation, figure out what's going on. You need to orient yourself, do some analysis. You need to decide what to do, and then you need to do it. This is not done by committee, because what happens? You get shot down and die. This has to be super snappy, super quick. And this is his whole concept of agility. Who flies fighter pilot? Who's a fighter pilot here? Right, this doesn't apply to any of us. So there's a guy called Steve Adolph, and he took this concept and he said, well, how can we apply this to the software world? And he basically wrote this paper, which you can Google for. And the conclusion he comes up with is that agility is relative and time-based. So in other words, it's about moving faster than your opponent or your environment. So let's imagine you're working for a massive organization, and you are shipping software once every year, but your organization is changing once every 2 years. You are, by definition, more agile than the environment. Now let's imagine you're a lean startup and you need to be releasing software every other day, but your architecture is restricting you and you can only do releases once a week. Now you're less agile than your environment. So this is the whole time-based relative thing. The essence of John Boyd's OODA loop is essentially this: inspect and adapt. And this is one of the things we see agile people talking about a lot. Right? So we look at what we've done and we change it, we adapt it. This is how we evolve. So how do we apply this concept to an existing system, an existing software architecture? So how do we look, how do we inspect a system? Well, one way to do this is to look at the code. But if we've got 2 million lines of code, that's going to take a long time. The other approach is we draw some pictures to summarize our software system. Who here draws pictures of their software? Less than half. Who uses UML to do that? 1, 2, 3, 4, 5, maybe 6. Right, it's a much, much smaller number. UML is one of the things we have as software developers. It's one of our tools to describe software systems. But what I've figured out over the years is that not many people use it. So I've asked that question to audiences and conferences and training courses in the US, all around Europe and China. And I get the same sort of response. So 9 out of 10 people don't seem to be using UML. And one of the things I've discovered is that software teams find it really hard to visualize and therefore describe and communicate their software systems. Often these diagrams that are produced don't make any sense at all. And they're often stuck on the wall and ignored. So what are people drawing? If they're not using UML, they must be doing, I don't know, no UML or something. Right? It's everything that's not UML. It's just boxes and lines pictures. And this is fine, but these pictures need to make sense. And this is where we get into a whole bunch of interesting conversations about diagramming software architectures. And one of the pitfalls that people fall into is, right, let's diagram the entire system on a single whiteboard or a single piece of paper. And guess what? It doesn't work, because you're trying to show too many different aspects and perspectives. So when you read those classic architecture books, they often talk about these things, views. Right, so we have a logical view and a conceptual view and a physical view and a development view and an implementation view, and the list is as long as my arm. And that's fine. Basically what that's saying is we should look at our software systems from different perspectives, but here's the catch. Do the names of those views make any sense whatsoever? So I've been in meetings where people have argued that there is a difference between a conceptual view of my software and a logical view. What? They sound like the same thing to me, but maybe I'm just too stupid to understand this. If I'm a developer writing lines of code, there's something called the development view or the implementation view, which is basically, it summarizes the code somehow. But if I'm physically creating lines of code, if I'm physically creating files, is that not called the physical view? No, but the infrastructure people have the physical view because that represents the physical infrastructure. But what happens if your infrastructure is not physical and it's virtualized? Do you have a physical virtual view? Right, the whole thing doesn't make sense because it depends who you are. Was that a modem? Brilliant. We should hook it up to the SNES outside. The point of these different views is to look at software systems from different angles and highlight different things. If I'm trying to draw a picture of a software system, this is really the basic question I'm trying to get to the bottom of. Right? Is this how we actually built the thing? Is this what the system looks like? So that's all I'm trying to get to. When I'm inspecting a software system, I'm trying to answer this question. Now, I personally do use UML for some things. And let me caveat that. I tend to only use UML for the lower level information. Class diagrams, sequence diagrams, state charts, activity diagrams, that kind of thing. But I don't think UML is a very good way to describe an entire software system. In other words, it's not a very good tool for describing software architectures. And the thing with UML is it gives you two things. Right, so on the one hand, UML gives you a set of abstractions to describe your software systems with. Classes, components, packages, deployment nodes, the list goes on. On the other side of things, UML gives you a standardized notation. Essentially a bunch of boxes and lines with funny little squiggles and symbols on to represent these abstractions over here. I don't really care how people draw pictures. Right, so I jet around Europe teaching people how to draw pictures, and basically I don't care how people draw pictures because I'm much more interested in the abstractions they use to describe and think about their software. And for me, it's the abstractions that are much, much more important. Now, this might sound slightly foolish, but let me give you a real concrete example of this in action. Let's pop down to the local tourist office and get 2 maps of London. The 2 maps of London will show exactly the same things. They'll show the River Thames and the underground maps and the points of interest and the major roads, but they might use different colors. They might use different symbols to represent things. How do we decipher these things? Well, there's a key or a legend on the bottom corner. All they're doing is they're creating a self-describing notation. That's exactly the same thing we need to do when describing software. So maybe we should dump this whole complex notation and just create nice self-describing notations based upon a simple set of abstractions. Okay, so what are these abstractions? Well, this is how I do it. So I think of a software system as being made up of a number of what I call containers. Now, a container is basically something like a web server, an application server, a database, a file system, a browser environment, a mobile device, etc., etc. It's essentially something that needs to be running somewhere that you can put code or data. For me, my containers are made up of components. Now, I know this is a hugely overloaded word. Essentially, what I'm talking about here is a bunch of stuff related with a nice clean interface on top, something we can substitute in and out. You might want to call these modules or services, don't really care. And because I'm mostly dealing with Java and .NET systems, my components are made up of classes. Right, so that's it. It's a really simple tree structure. Software system has a bunch of containers. Inside those are components. Those things are made up of classes. So that's how I think about software systems. And this basically comes onto my C4 model, which is all about how to, therefore, diagram and describe a software system. So I'll start with a context picture, which kind of sets the scene, and I'll show you some quick examples in a minute. I'll then dive into detail and show a picture of all the containers and how they interact. I'll then open up each interesting container in turn and show the components inside it. And although this has got C4 at the top, I normally stop here. And there are already 3 boxes. The 4th one is classes. If you want to do class level modeling, if you want to, you can. Sometimes I do, sometimes I don't. Most often I don't do this. And what this model really does is it puts the static structure of your system at the core. So this is about representing the static structure of your system, and then once you understand the static structure, everything else kind of fits in nicely around it. You know, you can have a model of your infrastructure and how your containers, your web servers, your app servers, your databases map onto your deployment infrastructure. You can have collaboration sequence diagrams across your components. You know, the world's endless. Monkeys. When I moved back to Jersey 5 years ago, now Jersey's only 9 miles by 5. It's tiny. It does have an airport. And the population is 100,000 people. And when I moved back to Jersey, I found it really hard to find other people who were doing IT stuff. And when I discovered their Twitter accounts, blogs, that kind of thing, I wanted to keep a list of them. So I built this. It's a really basic content aggregator. It's written in Java, Spring MVC, running on Tomcat, MongoDB, MySQL. And basically it lists local people, businesses, user groups, tweets, blog posts, jobs, that kind of thing. So here's a basic context picture to describe my system. This is my system in the middle. Those are my key types of users at the top, and these are my key system dependencies. That's all this diagram shows. If I then open up the monkey, we see inside his head, this is the containers view. So basically it says my tech tribe site is made up of a web server, which is Apache Tomcat. There's a standalone process for doing content updating, talks to Twitter, GitHub, blogs, and there's a bunch of data storage stuff in the middle. And then I can open up each of those boxes in turn and see the components inside them. So this is how I'm showing my decomposition of my standalone process into a nice bunch of components. And that's it. Right, it's essentially just drilling down to different levels of detail. And basically these sketches are like maps. So if you go into Google Maps and you do a search for Jersey, you often get this as your starting point. Now this is great if you want to know what's in Jersey and how it's sliced up, but it's not very useful if you don't know where Jersey is. So if you're on your phone, you need to do the pinch or inverse pinch to zoom out, and eventually you get to that view. The diagrams are the same. What we want to do is look at our system from different levels of abstraction. Sometimes we want to be down here. Sometimes we want to be up there. And this kind of simple model gives us the ability to do that. So that's one way we can inspect and see what's in a software system, right, by drawing some pictures. So to answer the second part of this question, how do we adapt this system? So once we know what it is, how do we change it in the face of changing requirements or whatever? This is a little bit more tricky, because often some of the changes we want to make, they're not just adding new features, they're changing our system architecture. Big, scary, hairy changes. And this is where we talk about architecture refactoring. Show of hands, who thinks architecture refactoring is hard? And there's a good chunk of people. There are some brave souls here who go, no, it's easy. Is it hard? I don't think architecture refactoring is hard if you know what you've got and you know where you want to get to. But people often don't know what they have, and they have a vague idea of where they want to get to. The thing that concerns me in the industry at the moment is we're all going microservices crazy. And people can't build monolithic systems in a structured way. So how on earth are we going to build microservices architectures in a structured way? We're going to move from big ball of mud to distributed big ball of mud. It's still going to be a mess, but now we've got networks in the way as well. So this is why I think we should put some emphasis on understanding what we really have and where we want to get to. Now, those diagrams I showed you, and this is the same thing applies to all architecture diagrams. Imagine you have a code base with 3.5 million lines of Java code. Do you really want to draw a diagram with 3.5 million boxes on? No, that would be absolutely crazy. So what we're doing when we're drawing our pictures is we're talking about abstractions. Right, we're talking about abstract concepts. We're not talking about lines of code and classes. We're talking about bigger chunks of stuff. Components, services, modules, layers, however you want to break your systems up. And this raises a kind of interesting question. Those boxes that we put on the pictures, can we see those in the code? So do the abstractions on the pictures match stuff in the code? Can we find them easily? And the answer's sometimes, but more often not. Why? Because although we're thinking abstractly in terms of components, we're writing classes. We're writing classes and packages and interfaces and that sort of thing. Because, for example, Java doesn't have a services or component keyword. There's no way to define a component in the base Java language. You have to use frameworks like Spring, for example. So what you often get is this pretty diagram with all this really nice information about what we think the architecture looks like. And then when you look at the code, it's a complete rat's nest. Anybody seen this? Yeah, that's most of the systems that I see. There's a guy called George Fairbanks who wrote this book, which I definitely recommend reading. It's called Just Enough Software Architecture. And he calls this the model code gap. And basically what he says is, when we think about architecture, we're talking in terms of abstract concepts, but these abstract concepts never quite manifest themselves cleanly in the code. And he has a way to solve this, right? So he says, well, all you need to do is use an architecturally evident coding style. So in other words, if you're building components, use a naming convention which dictates this thing is a component, stick component at the end of the name. Maybe we could use a way to organize our code base so our components sit within nice, neat packages or directory structures or even, IntelliJ projects. There are a bunch of ways we can organize and structure our code base to reflect the mappings on the architecture diagrams. Who thinks they do this? Oh, wow, that's a really small number, like 1, maybe 2. There's like half hands here. Yeah, it's something that sounds so completely obvious, yet we don't do it. I briefly showed you some architecture pictures on my Tech Tribe site. So the obvious question is, those diagrams I presented, do they reflect the code as well? All the code's on GitHub, so you can go and have a look. But I can save you the pain. The answer is yes. Because I am epically awesome. Now, apart from me being a bit of a smartass here, the more interesting question to ask me is, did my code start out that way? And the answer's not really, right? And the reason I say not really is because although my diagrams show components, my code was built in layers. So to give you an example, on one of my diagrams there's a tweet component, and a tweet component is basically a way to get tweets from a MongoDB database. It's just a CRUD component. The first implementation of my tweet component was essentially exactly what we always do. So there was a services layer, and there was a data access layer. And there was a nice interface because I was using Spring and dependency injection, and there was a default tweet implementation down here. And all that would do basically was delegate down to this data access object, and there was a Mongo implementation. Fairly common pattern. See this everywhere? But that's not what I drew. On my diagram, I drew a tweet component. I bundled all of this stuff up into one box, but in the code it doesn't exist. So I've created this fantasy mapping. Right, I'm just lying about what my architecture looks like. Oh. But I like my diagram. It's nice and clean and simple. But it's lying. 2 options. Number 1, change the picture. No, I'm going to get a complex picture. Number 2, refactor. So I refactored, and now my code looks like this. So I've adopted an architecturally evident coding style here. And now what I have is I've essentially jammed the services and DAO layer into one thing. So I now have a tweet package with a nice component interface and stuff inside it. And the stuff inside it's all package protected, so it can't be seen from the outside world. This starts to raise a bunch of interesting questions. Well, Nave moved away from a layered architecture, and that's bad. Well, not really. Layered architectures are just one way to do things. And there are a bunch of problems with layered architectures. Because this is public, anything can call it, which means they can bypass my service interface. This is how a lot of layered systems start out really nice and neat and clean, but end up in a big ball of mud. I still have layers, right? I still have a services layer and a DAO layer, but they're just inside my component. I can still change out Mongo to Cassandra. That's absolutely fine. That's very, very quick to do. But you can't do unit testing now because you've not got a DAO interface. Well, I have to jump through some hoops, but why should I do unit testing? Right, so let's attack this from a different perspective. What benefit is there for me unit testing this thing in isolation? None. So all I'm going to do is I'm going to component test right through to the Mongo. So maybe changing our architecture gives us a different way to think about how to test our systems. There's this whole interesting debate at the moment in the industry about unit testing is dead and TDD is dead and all that sort of stuff. Test-induced design damage. This sort of thing solves a bunch of those problems. I'm not saying it's a silver bullet, because imagine this was backing off to a third-party asynchronous system. I probably do want the ability to mock that thing out. But there are some options here, right? So it's about opening some doors and providing some options. So since my code actually looks like that now, I should be able to automatically generate some pictures. And that gives me a really, really easy way to inspect my software system. But we can't do that. So we do have some tools in the industry, Structure 101, Lattice, Endepend, Sonar, Architect, etc., etc. And these tools are generally dependency management tools, and they'll draw some pictures of your systems. But they don't draw components, do they? Because they don't know what a component is. All they see is packages and classes. So this is why whenever you plug those tools into your code base, it says you've got a mess. So I know that. I didn't need to spend £3,000 telling me that. So that's another issue that we're having in industry. Something I am doing, and this is definitely a work in progress, is I'm trying to build a diagramming tool based on my C4 model. So basically, you create a simple model underneath it, and it will generate some pictures, but also there will be an API where you can plug in a build tool, and it will go rip through your code base, find your components, and upload them to the tool. So I'm working on a way to auto-generate some of these diagrams, provided you use a nice, clean, structured code base. But that's an aside. What I'm really saying here is make sure your architecture matches your code. Right? That's the thing we really want to be striving for. If we're taking all this time and trouble to draw some pictures and inspect our system, I want to see those things on the diagrams in the code base. So aligning the architecture view and the code view of the world is a very, very easy way to do this. And simply understanding what you have, honestly, provides you a level of agility right from the get-go. Because we have an honest view of what we have in the software system. And then we can start thinking about how to change it. You don't get this for free, though. Right, so if you want to create an agile architecture, you need to put some conscious effort into doing so. And this is where the whole upfront design thing comes into play. So what I'm saying is, if you want to be agile, you need to do upfront design. What? That doesn't seem to stack up at all, does it? There's a longer conversation here about what just enough upfront design means. But essentially, for me, it's about two things. It's about understanding the structure of what you're going to build. So imagine we have a blank sheet of paper and some requirements. For me, doing just enough upfront design is going down to the level of understanding what it is we're going to build at some degree. Why? Because I want to create a shared vision that a team can work from. Imagine we're a team of 10 developers and we're going to build something from scratch. I want all of us as developers to be building the same thing in a consistent way. Now, this sounds very fluffy, so how do we actually do this? Structure is important, right? So architecture is essentially about structure. We've got a bunch of options here. Let's imagine we're building a website. We could just draw one box that says website. That's not going far enough. We could do class-level design of every single user story. That's going too far. There's a nice midpoint somewhere in the middle. And for me, that's components. Right? For me, it's about breaking your system up into components or microservices. Something that gives us a framework, something that gives us a structure to work with. And then the diagramming techniques provide a way to visualize and communicate that structure. And this is a great way to introduce essentially technical leadership back into teams. So this is why I'm a big proponent of sketching, right? I think every software developer should learn how to sketch. It would be fantastic if you could ask any single developer on a team to diagram a system, and you'd get roughly the same thing. As I said, I don't care about notation. What I'm really thinking about here is the abstractions. That's what's important to me. And if all of the team have these same abstractions in mind, you can have much, much better conversations. Right? You can start talking about containers and components and changing things and adapting your architectures. Extreme programming talks a lot about collective ownership of the code. This is much, much easier if everybody can step back and see the bigger picture. In other words, if you have a way that everybody can see the architecture, now you know where you're talking about in your architecture when you have code discussions. Line 2, Agile Manifesto, what's it say? Something like, don't write documentation ever again. I'm summarizing. A lot of people have dumped documentation. The Agile Manifesto doesn't really say that, but that's people's perception. And pictures are the simplest form of documentation. So again, we can start factoring in some lightweight documentation here, which again gives us a really good starting point when we need to change and adapt our architectures. The whole just enough thing is more about just drawing pictures, though. It's also about risks. So you're starting a new software project, you're building a new product, there are going to be some risks. Security breaches, they're fairly popular these days. Scalability issues, availability issues, performance, systems that are too slow, these sorts of things. So we need to basically look at the highest priority risks and make sure we have a plan for mitigating them. And this is something else I factor into my just enough upfront thinking. Basically, this is about putting some firm foundations in place so that the software we deliver works. Right, that's it. This opens a whole can of worms. Who owns risks on project teams? Well, normally it's a non-technical project manager. I'm not sure that's a good idea. But how do we even get to a list of risks to look after in the first place? We could draft out an email, dear developers, please send me a list of all your risks. Delete, right? It's just boring. We don't want to do that. We just want to write some code. So I teach people this technique I call risk storming. And it's a kind of game storming, innovation games inspired way to get to a list of risks. Step 1 is you draw some pictures, ideally at different levels of abstraction, because then you see different things. Step 2 is you get a bunch of people together, architects, developers, project managers, testers, support people, whatever. You get them to look at the pictures, which hopefully have some sort of proposed design on there, and you get them to identify the risks. Write them on sticky notes. Step 3, put the sticky notes on the picture. So it's a nice collaborative kind of gamey way to get a list of risks. You obviously need to do something about these risks, but that's where the whole, prototyping, spikes, slices thing comes into play. So when I'm talking about just enough software architecture, it's really about putting some firm foundations in place for two things. Number one, the team. So we're building the same thing in the same way. We all have a shared understanding of what it is we're doing. And number two, some firm foundations for the actual products we're building. Making sure the product's actually going to work. Make sure security and scalability is baked in if it needs to be. And this is all about structure, understanding the structure essentially, looking after the risks, the key risks, and putting that vision in place. So this is basically about technical leadership. And for me, that's exactly what the architecture role is all about. It's about technical leadership. Have I scared anyone? Does this sound like big upfront design? I hope it doesn't. That's not what I'm trying to get to here. What I'm trying to get to is, we have some requirements. Even if it's a high-level backlog, it's fairly easy to come up with a design down to components level in a number of hours or days. This isn't weeks and weeks and weeks. This is hours and days. So this is really short-circuiting the whole design process. Again, there's another question here about architects. So who does this work? Is it just one person? That one guy on the team who has architect on his business cards? Or is it the whole team? And there are differing opinions about this. The traditionalists will say it's one person. The agile people say, well, we just self-organize and we share the rollout. Both can work. So I'm not talking about big upfront design. And I'm not talking about just hacking and hoping for the best. I'm talking about putting some structure in place. But that can be done by one or many people. There's a guy called Roy Osherove. He's very well known in the .NET community. And he's written a book called Notes to a Software Team Leader. A lot of agile people are going around saying, we should just have self-organizing teams and share the roles out. But that doesn't work for everybody. And this is exactly Roy's experience. And in his book, he basically says there are different types of teams at different levels of maturity. And those different types of teams respond best to differing styles of leadership. So the more chaotic traditional teams generally respond best to a single architect. Right, so one person who's responsible for creating and sharing the vision. I'd probably say, my gut feel, this is where most people are. The higher performing teams, they do share the rollout between many people. And those teams generally work because they have a lot of experience between them. So there are different types of teams and they respond to different styles of leadership. And my advice is basically figure out where you're on this scale and make sure you've got the appropriate amount of leadership, technical leadership, in other words architecture, in order to do this stuff. Cool. So we've talked a bit about agility, and we've talked a bit about adapting or inspecting software systems so we know where we are, and therefore that provides us a basis to adapt and change our software systems. And we've talked a bit about how we do some design up front so we can weave in the appropriate amount of structure and therefore agility. How do you actually get teams to do this? Right, so we can come to conferences and read books, and this is all sounding great, but how do we actually get people to change their behaviors? This is a tough question. Right, I see lots of teams out there who are failing for some very, very basic, simple reasons, and we can talk to them until the cows come home, and they will not change the way they're doing stuff. And part of my role at the moment is to help such organizations actually make some positive changes. And the first thing we can do is make sure everybody understands what software architecture is and the benefits of thinking about software architecture and what it provides. And basically, it's introducing structure. The problem is software architecture has got a really, really bad reputation. Right? It's seen as this kind of grandiose, conceptual, abstract thing which you have to get into at some point in your career. It's not. It's just understanding the structure of what you're building and how you get to that point. You know, there are a bunch of things which you need to take into account, particularly if you're starting with a blank sheet of paper. And it's about understanding those things, the risks, the non-functionals, the constraints, and getting to a solution. That's all architecture is about. So we can demystify architecture for everybody and bring it kicking and screaming back down to earth. But it's not just developers. It's not just us as developers who need to understand what architecture is. We need to make sure that everybody else on the team and in the organization also gets what architecture is. True story. I did a training course for a company somewhere in Europe last year. And I was brought in by the developers because the management team of this organization had been sent on an agile transformation course. And the management went through this kind of agile course, and they came back to the development team, and their orders to the development team were basically, we need to be more agile, stop doing stuff that doesn't add value. And they basically said, you're not to draw any pictures or do any documentation. And you're not to do any upfront thinking, we just want you to write code because that's what we believe agile is about. So they got me in to do my normal architecture course, and I also had to do a half-day compressed session to explain to the management team that architecture is not this big upfront wasteful activity. It's about providing and injecting some structure and therefore some technical leadership. So this is why everybody needs to understand what architecture is about. We need to demystify it for everybody. So yeah, let's not, architecture is not drawing a cloud and an arrow and a database. It's about getting into something slightly deeper than that. And this is why, from my perspective, architecture needs to be grounded in reality. One of the simplest ways to do this, if you're drawing architecture pictures, one of the simplest tips I can give you for bringing those architecture pictures back down to earth is to put technology choices on your pictures. I'm sure you've seen this. You get these grandiose kind of logical views of the world with lots of concepts and components on, and they just sound fluffy and abstract. If you put tech choices on there, it suddenly brings them back into the developer's domain. Right, it's a really, really simple thing we can do. For those of you who are, following agile processes, I know that's the wrong thing to say, for those of you with a more agile mindset, should we say, if you're having retrospectives, talk about architecture in your retrospectives. This is another good way to weave in architecture into your ways of working. Are we doing too much architecture? Are we drawing too many pictures? Is there too much structure? Should we relax what we're doing a bit more? You can have these honest conversations in your retrospectives and adapt your architecture practices. The best advice I can give you for teaching people about architecture is simply this, right? Do some katas. We spend lots and lots of time writing code. We spend lots of time practicing how to code. How many people here have architected 5 or more systems? It's a small number. 10 systems? Yeah, even smaller. Architecting systems is something that we don't get to do very often, but we can practice. And the way I do this is I use a really, really simple set of requirements. It's for a financial risk system. if anyone wants a copy of this, blast me an email, I'll send you a copy. It's a 4-page PDF. Really simple set of requirements, and basically what we do is we get people into groups, 2s or 3s or 4s, and we say, go design a solution to this. And the deliverable is basically to draw one or more pictures to describe your solution. And we give people about 90 minutes to do that, and they come back with some pictures, and we critique them, and we look at the designs, and then we do another iteration after we provide some guidance and feedback about how we can effectively diagram these architectures and describe them, and we talk about abstractions and that sort of thing. And this is a really, really simple thing you can do in your offices in the space of a morning. And it's a great way to get people practicing a bunch of things, really. Collaborative design. This has its own set of challenges. It's really amusing to see people who have never worked together before trying to design a solution to a software system, especially if you have a Java guy and a .NET guy and a Ruby guy. It's like, which technology do we pick? You have all these funny arguments. It's also a great way to practice things like architecture sketching. This is a great way, as I said, to inspect a system. And it's also a great way to demonstrate the power of doing just enough upfront design, particularly if you weave in some of the risk-storming stuff towards the end of the session. Because giving people an architecture kata does force questions. Well, how much design should we do? What are these diagrams you're expecting? Are they class diagrams? Or should they just be one big box saying risk system? Yeah, it's about getting them to explore the different levels of design. So that's my recommendation. Go do some katas. So what? I'm here at a conference, it's 2014, and I'm still talking about agility and architecture. I tried to get an article published in one of the academic papers. Don't ask why. It's a long story. And the peer reviews I got back basically said something along these lines. Right? So the subject of agility and architecture has been discussed. We know all the answers. This was from the academic community. Now, this room is full. I'm doing this talk all over the place, so clearly there's an interest in blending architecture and agility. So although it's old news for some, this still matters for a lot of us. And to kind of put this in context, someone I know wrote this great blog post, which you can go and have a look at, and basically he says, as developers, we focus on developer stuff, and very few of us understand what architecture is all about. And if we want to contribute to the design of our systems, the big picture, if we want collective code ownership, we need to get better at understanding and practicing software architecture. So that's basically my closing point here. My closing point is for those of us who do understand this stuff, it's our responsibility to go and educate everybody else. So then we can stop having this discussion and start building cool systems that actually work. Thank you very much. So we have 5 or so minutes for questions. Feel free to fire away, and there's the code for the book. Yes? Right, so the question is, I talked about aligning the architecture view and the logical view with the code. What happens when you want to describe things that don't easily fit onto diagrams, for example, things like code reuse, patterns, that sort of thing. So what I'm trying to do here is I'm trying to break down my system into a bunch of coarsely grained things, and ideally there'll be a bunch of stuff happening inside those things. That's where a lot of the patterns will be, for example, design patterns. Things like reusable code, on your architecture diagrams, just write a note somewhere that says, actually, there's a bunch of reusable code in here. The other option is to have separate boxes representing your reusable code, superclasses and shared exception types and things. I would avoid doing that and just basically put a note somewhere that says, by the way, there's a bunch of shared code behind this. As developers, we can go find that stuff easily in our IDEs and tooling. Yeah, so the follow-up comment was, this seems to be at odds with my one-to-one mapping of architecture and code. If you look at the Tech Tribe's code base on GitHub, the majority of it matches pretty much one-to-one with the diagram. There is a domain package with a bunch of domain objects, which I don't show in my architecture pictures because it's just kind of floating around everywhere. And there's also a utils package, yay. Right, and the utils package has a bunch of base classes, and it has a bunch of shared code which is used by all the components. Again, I kind of hide that off the diagrams because from an architecture perspective, I don't really care. It's just an implementation detail, essentially. Any other questions?
Are you able to be effective? So, are you able to convince the developer to educate? Can you go to a company that is poor with these skills and teach them how to improve?
Right, so the question is, can I really go to a company who's poor at these skills and teach them to improve? And the answer is yes. And how long does it take? The simple answer is that the whole purpose of doing the architecture katas, so we spend about 90 minutes, some feedback time, another 90 minutes, some more feedback time. That architecture kata is normally enough to get people to understand the underlying concepts and actually put it into practice. And one of the things I often do with teams is I take their code base, and instead of using my risk system, I get them to draw diagrams of their own systems. And this is absolutely fascinating because what people normally draw is a layered architecture, nice straight lines all going one way, and then you open up the code base and guess what happens? We're bypassing things, we're going back up. And this is a great way for them to experience that actually, we should put some structure into our code base. So it's very, very simple to do, particularly if you use their own systems. Any other questions? Yeah.
How do you keep it from getting out of sync with your architecture diagrams and the actual code?
So the question is, how do I keep my diagrams and my code in sync? So until my marvelous tool is born, which is not ready yet, the simple answer is just keep your pictures up to date, iteratively. So if you have a definition of done or a definition of ready for your user stories or tasks, add a line to the bottom which says, have you updated the documentation of the diagrams? Now, if you have architecture diagrams that present a nice abstract view of your system, which you can see in the code, you're not showing lots of detail. And what I normally find is you can add features to a system, but your architecture doesn't change. So actually, the diagrams don't need to be changed that often, particularly if you have a kind of stable architecture anyway. Good question. Anything else? No? Cool. Well, thank you very much. And please don't forget to vote. Enjoy the rest of the day.